Previously, in our MPLS class, we saw what VRF is. VRF is a virtual route forwarding. Using this VRF, I can have multiple control planes inside a physical router. Usually, one physical router will have one control plane, but by creating VRF, we can have multiple control planes. Why someone needs multiple control planes? Because the router connects to multiple customer. In order to keep the customers traffic forwarding separate from one another, we have to maintain separate routing table for each customer. That's why we need VRF. Now, to identify the VRF, you use a 32-bit colon 32-bit totally 64-bit value called route distinguisher. That route distinguisher helps to distinguish the customer's route. Now, we also name the VRF, but the naming VRF is for you and me, not for the device to differentiate the routing table. If I say VRF blue, VRF green, that's two separate control plane I'm creating. But the blue and green is not sufficient for the routers to differentiate. That is why it needs route distinguisher. That VRF name is locally significant. I told you this one in the previous class. For a customer, you can have different names on different provided edge router. Even the route distinguisher can be different for each PE router. Repeating again, route distinguisher can be different for the same customer. Route distinguisher can be different on different PE routers for the same customer. So the VRF name can be different for the same customer on different PE. Not only that, even the route distinguisher can be different on different PE. For example, so I'm not teaching anything new, I'm just revising what we did in the previous class. We got a provider edge. We got provider edge routers. These are only provider router. It's not a provider edge. The provider edge is this one, PE1 and PE2. This is what provider edge is. And this is a service provider network. Now, why do you call that router as a PE router? Because it connects to customer. So here we got a customer called green. The same customer is also available in the remote location. There is another customer called brown, who is also available on the remote. Now for these customers, we are going to form a tunnel between this PE router, a tunnel, which we called as MPLS layer 3 VPN. Some people will call it as MPBGP tunnel. Actually, when you say MPBGP tunnel, it doesn't mean layer 3 VPN. It can be any VPN. It can be even layer 2 VPN. So that's not the right way to say MPBGP, MPBGP without knowing what it is. They say simply MPBGP. MPBGP also means VXLAN EVPN. MPBGP also means VPLS. MPBGP also means segment routing. Many things. Because MPBGP, multi-protocol, it is simply meaning multi-protocol in which what exactly you have to say. In MPBGP, what I'm doing is layer 3 VPN. That's one of the MPBGP's feature. So we got a layer 3 MPLS VPN between the P1 and P2 so that the green routes that are advertised from G1 will be taken into this VPN and given to this G2 here so that G2 can ping G1. Members of G1 and G2 can communicate over the tunnel. So the purpose of tunnel is to distribute the route from P1 to P2 so that there is no need for the provider only routers like P1, P2, P3 to learn those customers' route. That's why we need to do VPN, which is our today's focus. We are going to focus on how to configure this VPN. Earlier in our MPLS session, we understood why VRF. Why? So that the routes advertised from the green customer will be maintained separately in the green routing table, and the routes that are advertised by the brown customer, brown customer, a separate routing table, green customer, a separate routing table. So the routes that are advertised from brown customer will go into brown routing table. The routes that are advertised by green customer will go into green routing table. For which we need to do what? We need to make this port, this interface, as a member of green VRF, and this interface as a member of brown VRF. The green and brown may be the name given for the VRF, but you also need to give a route distinguisher for the VRF to come active. So I'm going to give a VRF name for this. Green, and route distinguisher 1:1. And for the brown, I'm going to name it as brown 2:2. Now when I configure the brown here, I can give different name for brown. I want to give the VRF name instead of brown here, I'm going to give khaki. That's the VRF name. In the route distinguisher, I can give 22 colon 22. You understand what I'm coming to say? Though the customer is brown 1 and brown 2, same customer, the VRF name can be different. Even the route distinguisher can be different. Okay. So for green, when I configure VRF, so for this route distinguisher, I'm going to give like 11 colon 11, and the name can be Pachai. You see, different VRF names for the same customer is okay. Different route distinguisher for the same customer is okay. Because the purpose of route distinguisher is to simply say who is giving this route updates. This is not going to be a significant ID for the receiver. We have another one called route target. That has got some significance in the VPN. So this is just to simply say route distinguishers are simply to say from where these routes are coming. But to whom it has to give is determined by route target, which we'll be seeing now. Route target. Route target is also a 64-bit value. That is also represented as 32-bit colon 32-bit. For example, all the routes of green 1, I'll take it and export it with the route target value. Let's say it can be same number also. I'll say export it using 1 colon 1. Nothing wrong. You can use the same route distinguisher as a route target value, or if you want to use a different number, you can very well do it. 7 colon 7. That's what I'm exporting. We call it as route targets, RT. Whereas this one is RD, route distinguisher. So RT export is this. RT, if I export this here, then this, if it needs to import it, download it, I export it with 7 colon 7. So whoever has got import 7 colon 7, import 7 colon 7, they will download the route into the routing table. And if I take G2 root and export 17 colon 17, here I need to import 17 colon 17. So that the routes given by G2 can be downloaded in green VRF or PE1. Likewise, between browns. I'm going to use for both import and export, I'm going to use 12 colon 12 for brown. So it is the route target that determines who will download what I am sending. If my export value and the receiver's input value matches, receiver can download it. So inside the VPN, both the brown as well as the green routes are going in. They don't get mixed because the route targets and the route distinguisher from where it is coming is attached in the VPN tunnel. So they don't get mixed. There won't be any confusion whether to think whether these routes are from that customer or this customer. Route distinguisher is differentiating that. and route target is taking care of to whom it has to be delivered. To whom it has to be delivered what? Delivered what? Route updates, not your packet, not your ping packet. So using the route update, routing table will have a route. Using the route, packet will be forwarded. Route target and your packet, your FTP packet, your telnet packet and all not connected. Giving routes to whom to give, whom not to give is determined by route target. So if the routing table has got the route, then it is going to ping and there is no need for route target, only the VPN labels, which we call the service label, and then the transport label between the P's determine the packet flow, right? So VPN between these PE routers, uh, which we have not configured yet. We just configured one VRF yesterday. I showed you how to configure. We'll add more customer and we'll have another VRF and then VPN between these two PE routers. And then you will see me, I will be using route targets. Earlier in our demo, we did not use route target. We used only route distinguisher. So when you do these things correctly, your layer 3 VPN is done, right? So any question?